Patty Simpson with Simpson Math. In this video, we're going to introduce polynomials. So here we have a polynomial, and this particular polynomial has 1, 2, 3, 4 terms. Each one of these we call a term. Each one of those terms has a constant out front, a number there. We call this number here a coefficient. This is a coefficient. Those numbers that are being multiplied times that variable are called coefficients. So here's a -2. That's the coefficient of that x. And even this last constant, he's a coefficient on an x there. Those are the coefficients. They're just constants that are multiplying. Then, for each one of our terms, there's also an exponent. This term has an exponent of 5. That's an exponent. This one has an exponent of 3. This one has an exponent of 1. And there's even a little x here that's x to the 0 power. Because remember that anything raised to the 0 power, any non-zero number raised to the 0 power is equal to 1. So it's like there's an x to the 0 there. So here we can, if we just look at each individual term, we call that its degree. It's the degree of the term. And when I look at the whole thing, we say that the degree here, this degree of that term is 1. The degree of that term is 0. So you could say those are exponents, but of each term we call them degrees. And the degree of the polynomial is that highest degree. The degree of the polynomial is the highest degree. So in this case, our degree of our polynomial is 5. Then we have our coefficients, which are these numbers out front. The leading coefficient, your leading coefficient, from this point forward, I'll just call him your LC. Your leading coefficient is just the one that's on, is the leading coefficient on the term with the highest degree. That's what your leading coefficient is. So in this case, your leading coefficient is the 7. So if you write your polynomial in descending order with your exponents or your degrees in descending order, your leading coefficient will be the one out front. So your LC, or your leading coefficient, is just the number out front, that constant out front on the degree, on the term with the highest degree. And then our degree of our polynomial, our highest degree, from this point forward, I'm just going to write degree of polynomial. Dope. I'm a Simpson, so it's just the dope. Now, let's look at a couple of polynomials and see if we can find that leading coefficient and that degree of the polynomial. So here's another example. Here we have y equals 5x cubed plus 7x squared minus x plus 9. And first, let's find the leading coefficient. So remember, the leading coefficient is on the term with the highest degree. And so our leading coefficient here is 5. And then the degree of the polynomial, or your dope, is 3. Because that's the highest degree. By the way, when your highest degree is a 3, we call this a cubic. This is a cubic function when the highest degree is 3. Then let's do another one. Let's look at here's another polynomial, 7x squared minus x minus 5x to the 4th plus 9. Notice that it is not written in descending order. Here, my exponents, or my degrees, are not in descending order. Let's rewrite this so that I have y equals negative 5x to the fourth, notice the negative is on that 5, plus 7x squared minus x plus 9. Now I have it in descending order, so my leading coefficient here is that one on the variable with the highest degree, which is a negative 5. So my leading coefficient in this case is a negative 5, and my degree of this polynomial is that 4. We say he's a quartic. This one we would call a quintic, but really once we get over 3, we just say this is a 4th degree polynomial, this is a 5th degree polynomial. That's really how we talk about them once it's over 3. So those are just some vocabulary there about the polynomials. Coefficient, terms, each one of those is a term, the degree or exponent. The degree of the polynomial is just your highest degree, and then your leading coefficient is the one out front. Now I keep talking about a polynomial, but what is a polynomial? Well, there's a few things that make up a polynomial, a few things it has to be in order for it to be a polynomial. First of all, the exponents must be non-negative integers. So what do I mean by that? Well, here's an example of one that has a negative integer. So 5x to the negative 2 plus 3x. So I'm talking about the exponents here, this 5, 3, 1, and the 0 out there. Notice that those are all not negative. They're all positive. Whereas in this case, it has a negative exponent. And remember that when we have that negative exponent, x to the negative 2 really means 1 over x squared. It reciprocates it. So this function is actually a rational function. It has the x squared on the bottom. This is not a polynomial, it's a rational function. So our exponents must be non-negative. Then they also must be integers. In other words, whole numbers, like this 5, this 3, this 1. Let me give you an example of one that is not an integer. If I have y equals negative 3x to the 1/3 plus 5. Remember that this 1/3, x to the 1/3 power, can be rewritten as the cubed root of x. So this is actually a cubed root function. I could rewrite that function here. So our exponents must be non-negative, and they must be integers. So no fractional exponents there in order for them to be a polynomial. Another thing that must be true in order for them to be polynomial is they must be smooth and continuous. So polynomials are smooth and continuous. So they're not going to have any holes in them. There's not going to be any discontinuity. It's going to be smooth and continuous. So an example of a polynomial is something like this. We've seen that before. A quadratic, or that parabola shape, is a polynomial. It's smooth and continuous. Here's another example of a polynomial. There's that cubic function that we've looked at before. It's smooth and continuous. Now, what do I mean by not smooth? Well, sometimes if they have a kink in them or a sharp turn, then they're not smooth. So our absolute value is an example of that. It's not smooth. It has that sharp turn. So this is not a polynomial. And then any that have some sort of discontinuity are not polynomials. So these are polynomials. So that's what makes a polynomial, is they have to have non-negative integer exponents, and they need to be smooth and continuous. And then we've learned a little bit of vocabulary. In our next video, we're going to look at the end behavior and how we can tell what's happening on the ends of our polynomials. Math Made Simple is some math. Thanks for watching.